Hi, my name is Michael Wang, a second-year PhD student in Professor Mung Chang's Edge Lab at Princeton University. Today I will talk about deadline-aware resource allocation for cloud computing, which is a project done in cooperation with Professor Tian Lan of George Washington University. The aim of this project is to achieve deadline-aware resource allocation for jobs across a network of independent computing clusters. However, this project greatly differs from many other scheduling projects because we explicitly emphasize the completion of jobs prior to their deadlines. Our goal for this project is to schedule jobs to maximize the product of prioritized utilities. To do this, we solve the time-based optimization problem shown on the left. This problem describes the following task. We wish to maximize the product of prioritized utility functions where the utilities are defined as a function of the completion time of each job. The constraints on the problem are the following. The job must receive a minimum amount of resources to complete. The cluster can only assign resources up to its capacity at any given time. Resources allocated at any given time must be non-negative. And finally, the job must complete before its deadline. There exist several difficulties in doing this optimization. First, each job may be unique. They may be defined by different time-dependent utility functions, priorities, minimum resource requirements, deadlines, and possibly even deadline types. In addition to this, the problem is a non-convex optimization problem. Not only is it hard to solve, but the techniques we can use do not guarantee a globally optimal solution. In response, we at Edge Lab have developed two heuristics, or simpler approximations, to tackle this problem. First, we have developed something we term deadline-aware feasibility, which checks if there is sufficient resources to complete a job by its deadline. This simply checks to see if it is feasible to accept the incoming job, ignoring the question of in what order and what amount of resources should be allocated to each job such that they finish in a way to maximize the product of their prioritized utilities. This heuristic is a linear program, which is very easy to solve. Second, we have developed a convexification procedure that is applicable when the utility functions are monotonic decreasing with respect to time. By penalizing resources allocated to a given job closer to its deadline, we aim to front-load resource allocation so that a job will complete prior to its deadline. This heuristic is a convex program, which is also easily solved with off-the-shelf commercial software. A comparison of the performance of both heuristics is as follows. Although the deadline-aware feasibility is less computationally complex to solve, we see that the convexification heuristic has a better cluster resource usage. The feasibility heuristic does not allocate all available resources to the active jobs during the first 7 time steps, while the convexification heuristic does so. This is a result of the convexification penalizing resource allocation closer to the job deadline. This front-loading is particularly useful if a future job arrives in the cluster and needs to be allocated resources to complete quickly. Our current work consists of the following. We are in the middle of setting up a Hadoop cluster on the Edge Lab, and we plan to implement both Edge Lab's time-based heuristics and George Washington University's resource-based heuristics, and run experiments using both heuristics for solving the deadline-aware resource allocation problem. For more details on this project, please contact us at mw7 or bbarath@princeton.edu. Thank you.